Welcome to All This Math. This is Professor Parker, and today we're going to simplify some algebraic expressions. We have a couple right here, and the first thing you should notice is that every one of these expressions have another expression within parentheses. So whenever you see an expression within parentheses and there's a number or a term outside of the parentheses, we should be thinking about something called the distributive property. I'm going to write it on the board. The distributive property. Let me get out the way. Distributive property. Basically what the term distributive property means is that whatever term is outside of the parentheses, we're going to distribute that term to every term inside the parentheses. So everything outside is given or distributed to everything inside. So what does that look like? Also, another thing to keep in mind is that you need to always ask yourself, like, what operation is taking place here? I see a 6, and then there's just a parentheses. There's no plus sign, no minus sign, no division sign, no multiplication sign. But because there's no sign there at all, that implies multiplication. That means that this 6 is being multiplied by the quantity x plus 3. And that's another thing, because when you read a problem like this out loud, the correct way to say it, right, in the accepted vernacular, is not 6 parentheses x plus 3 parentheses. We say 6 times the quantity, because this x plus 3 is called a quantity. This 2x minus 5 is called a quantity. It's an amount, right? It's inside of parentheses. So when something is inside the parentheses, it's called a quantity. Let me write that down. So when something is inside the parentheses, it's referred to as a quantity, right? So in number 1, we're doing 6 times the quantity x plus 3. So now how do we do that though? We basically do 6. We multiply each term one at a time. So we're going to do 6 times x. And 6 times x is just 6x, all right? Because really what's happening is there's an invisible 1 in front of this x. So really you could think of it as doing 6 times this invisible 1, which is 6, and then the x is kind of just there for the ride, right? And then you also do 6 times 3, and 6 times 3 is positive 18. Now, this is a very popular and common error with the distributive property, is that students will multiply the outside term by the first term in the parentheses and then forget or neglect to multiply the term by the other term inside the parentheses. Remember, when you think of distributive property, we got to be fair. We have to be equitable. If you distribute to the first term, you have to distribute to the other term. Or if there's 4 terms inside the parentheses, or like in number 3, there are 3 terms inside the parentheses. In number 3, every term is going to get this 4. This 4 is going to be distributed to every single term, not just the first term, not just the first 2 terms, not just the second term, not just the third term, but all 3 terms. So in number 1, 6 gets distributed to x and to 3, leaving us with 6x plus 18. So that's the final answer for number 1. Then we go to number 2. Number 2, we're going to have to do a little more work and think about some different things. We're going to have to think about some exponent rules. Because watch what happens. We have 8x times the quantity 2x minus 5, right? So what I want to do is I want to multiply 8x by 2x. And in order to do that, I got to multiply the coefficients first. The coefficients are the big numbers, the 8 and the 2. They tell you how many of the x's we have. So that's another important term. See, in math, we got a lot of vocabulary that we need to know. A lot of times we neglect the vocabulary, you know, but all these different parts of these problems and expressions have specific names. So we call, in this case, the 8 and the 2, we call those coefficients. In this x, this invisible 1, we would call that invisible 1 a coefficient, right? Now, we multiply the coefficients first. So 8 times 2 is going to give me 16. And then we multiply x times x. We multiply the x's together. Now, exponent rules say this. When you're multiplying terms and they're the same term, in this case, x and x are the same term, you take their exponents and you add them together. You write the term one time, but you add the exponents together, and that becomes the new exponent. For example, X times X, that's the same term. So I write X, and then this has an invisible 1, and this has an invisible 1 exponent. So what is 1 plus 1? 2. That's why this becomes 16x squared. So again, where did the 16x squared come from? Because that's another way I think we should start looking at math problems. We should always be able to explain intelligently where everything came from. Like, where did this 16x squared come from? Okay, let's talk about that. The 16 came from 8 times 2, because 8 times 2 is 16. Where did the x squared come from? It came from x times x, because when you multiply x times x, which is really x to the first power times x to the first power, you write the x one time, and then you add their exponents, giving you 2, and you write that exponent one time. All right? So that's where the 16x squared came from. Now, we also need to multiply 8x, or distribute the 8x to the negative 5. So now, here we have a coefficient that we multiply by the constant. Coefficient, constant. So 8 times negative 5 is not positive 40. Don't get it twisted. It's not positive 40. It's negative 40. All right? But there's an x along with the 8. So we can't leave the x out. We can't leave the x out. We need to include the x. So we have 16x squared minus 40x. Now again, where did this negative 40x come from? We should be able to work backwards and explain where the negative 40x came from. It came from, the negative 40 came from 8 times negative 5. 8 times negative 5 is negative 40. Where did the x come from? Well, the x was part of the 8x. So that just goes along with the rod, goes along for the rod. It's part of the product, negative 40x. All right, that's number 2. Now, number 3, here we have a quantity with 3 terms in it, 1, 2, 3. And outside the quantity, we have a 4. So what I'm going to do is I'm going to distribute the 4 to everything inside the parentheses. Everything inside the parentheses is going to get this 4, because we're fair. In math, we're fair. It's about balance and equality and equity. That's what math is about. All right. So we got 4 times 2x squared. We got 4 times 3x. And we got 4 times 7. All right. Now, 4 times 2x squared is going to give me 8x squared. Why? Because I multiply this 4 by the coefficient 2. So 4 times 2 gives me 8. And then what am I, well, 2 of what though? What did I have? I had 2 x squareds. Imagine x squared is a thing, right? So I had 2 of them, and then I take those 2 and I multiply them by 4. Now I got 8 of them. All right. So now I got 4 times 3x. Just follow the line. I do 4 times 3. That's 12. And then I have x. So 4 times 3x is 12x. And then I have 4 times 7, which is 28. And again, where did the 8x squared come from? 4 times 2 gave me 8. And then x squared was part of that factor, or part of that term. X squared was part of the 2x squared. So that's going to be part of the product. Where did the 12x come from? 4 times 3 gave me 12. And then x was originally part of 3x. So that's going to be part of that product. Where did 28 come from? Simply 4 times 7. All right. And that's just a little bit on how we use the distributive property. It gets more complex than this, but that's the foundation of how you use the distributive property. That's it. So please subscribe to the channel if you haven't already. Share the video, like the video, tell people about the page, tell people about what we're doing over here at All This Math. Come to the YouTube channel regularly. You know, we're building content on a regular basis, and we really want this to be a place for people to come to when they're in school and they don't understand their math problems, they don't understand their math homework, or whatever situation they're in. We want All This Math to be a place where people can come through and learn what it is they're responsible for learning. All right. And as always, remember that there's all this math all around you.